I would like to start our right triangles unit reviewing how to check if three values make a triangle in the first place. I always refer to this as beating the high score, as you might remember. If we beat the high score, then we are a triangle. So I'm going to take this first example, and we have 3, 4, 5. Right now, 5 is the high score. If I add 3 and 4, I get 7. 7 does beat 5. Okay, it beats the high score. So these numbers do form a triangle. So, yes. I'll do one more with you just to refresh, and then you should be able to do the others on your own. So if I take 1, 1, and 2, right now 2 is the high score. I add 1 and 1 together, and I get 2. 2 does not beat 2. These are not a triangle. They would not form a triangle. Okay. So you can check these other 4 on your own, and if you get it right, the check or X will appear in the "Did I get it right?" column. What we want to do now is take this idea of is it a triangle or not, and take it one step further. So once we know it's a triangle, we want more information. We want to know what type of triangle it is. To figure out what type of triangle we have, we're going to be working with Pythagorean theorem, okay, which is a squared plus b squared equals c squared. A couple of important things to know about the Pythagorean theorem. First off, it works for right triangles. A right triangle always has 2 legs. Okay, the 2 legs form the 90-degree angle. And then every right triangle has 1 hypotenuse. And that is always across from the 90. Okay, so if you can find the 90, the hypotenuse will be right across. The other super important thing to remember is that in Pythagorean theorem, A and B represent the legs. It doesn't really matter which one is which. So you could say this leg is A, this leg is B, or vice versa. I could have said this one is B and this one is A. It does not matter. All that matters is that C is always your hypotenuse. And it's always the longest side. So we're going to continue with that list we had on the first slide. And I want to talk about what I'm going to call level 2 of types of triangles. As a reminder, level 1, we took 3, 4, 5. We said 5 was the biggest. We added the others. And we said it was a triangle because 7 was bigger than 5. Okay, level 2, we're going to take those same numbers, but we're going to add squares. So level 2 adds the little 2's. Think of it that way. And we're still going to stay focused on that biggest value. Okay, my biggest value, 5 squared, which is 25. Notice I keep that isolated. So circle it, space it out, somehow keep that single number by itself. 3 squared is 9. 4 squared is 16. Now we're going to do the same thing we did before, and we're going to add. And then we're going to compare these. These are a perfect match. So these form a right triangle. Okay, so if they are a perfect match, it is a right triangle. Let me show you what happens if they're not. Obviously, I don't need to check 1, 1, 2 because that was not a triangle at all. If it's not a triangle, I stop at level 1. Okay, let me erase this. So the next one I want to show you is 10, 11, 13, which you should have checked. It is a triangle. So I'm going to go ahead and do level 2. Remember, keep the biggest one isolated. So I have 100, 121, and 169. When I put 100 and 121 together, I get 221. I look at my 169, okay, 221 versus 169. My 169 is too small. Okay, 169 is too small, so this is acute. So always focus on what's happening with the hypotenuse or your C value. Okay, C was too small. Original problem, C is perfect. This one, C was too small. Let's do one more. Let's look at the one down here at the bottom. The 24, 25, 40. Okay, we'll do our level 2. This is 1600. And then we have 576 and 625. Remember, keep C circled. I get 1201 when I put those together. So 1201 versus 1600. 1600 is too big. So it is obtuse. Because our C was too big. Okay, and just to give you a visual, what that means is we had a triangle and the hypotenuse was like this. It was too big, so we would have to open these sides up a little bit to meet the ends of the hypotenuse, thus giving us this obtuse angle. For the acute one, we had two sides, and then we had a hypotenuse that was too small, so we had to bring these sides in, making it acute. To summarize the key aspects of identifying what type of a triangle, okay, we use level 1, where we compare A, B versus C, and we want to beat the high score. Okay, to see, is it a triangle? Then we had level 2, where we did A squared, B squared versus C squared. And we had to analyze C squared. If C squared was equal to A squared plus B squared, we had a right triangle. If C squared was bigger than a squared plus b squared, we had an obtuse triangle. And if c squared was less than a squared plus b squared, so it was too small, we had an acute triangle. Most important thing though, focus on c squared. Is c squared just right? Is c squared too big? Or is c squared too small? And I like to put c squared on the left for that comparison. Now we're going to get into actual solving with Pythagorean theorem. So what we were just doing was just kind of verifying. So if we were given 3 values, what is that telling us about the triangle? Now we're actually going to find missing sides. For our first example, every time you're working with a right triangle, so this whole unit, you want to find your right angle and immediately draw an arrow straight across from it. That's your hypotenuse. Okay, it's really important to always isolate your hypotenuse. In this case, that's our c value. Okay, so remember a squared plus b squared equals c squared. If all we're working with is sides, we're going to use that. So I want to find the setup that has x as the isolated value. Okay, x needs to be by itself. Okay, so this is going to be my setup. It's the only one where x is by itself. And I want to actually solve this. So I'm going to solve it up here. You can solve it in the box below. So I have 9 squared plus 12 squared equals x squared. 9 squared is 81. 12 squared is 144. Notice I'm really just simplifying that left side. So now I have 225 equals x squared. To get x by itself, I need to square root. I type that into the calculator and I get 15 equals x. On this next one, just like I did before, first step, find your right angle. Directly across from it has to be your hypotenuse, okay, or your c value. So this side that has the 38 on it, that's my hypotenuse. It has to be by itself. This is the only one that has 38 by itself. Okay, so I have y squared plus 30 squared equals 38 squared. I'm just going to do some simplifying. Y squared plus 900 equals 1444. Now I'm going to approach it like I'm solving a normal equation. Y squared equals 544. I square root. And I get not a nice number. Okay, when you square root 544, you get y is about 23.3238 and on and on and on and on. And I believe this problem asks you to round to the nearest hundredth, which is 2 places. So 3 tells me not to round up. Typically, I would prefer if you simplified that as a square root. Okay, so just a reminder how we would do that. We would do that birthday cake approach. 544 divides by 2 to get 272. I can divide by 2 again to get 136. I can divide by 2 again to get 68. Again gives me 34. Again gives me 17. And then my last step, I can divide by 17. Get that candle on top. And remember, then we just pair things off. Okay, and cross 1 from each pair out. So those are the only pairs I can make. So the best answer would be y equals 4 square root of 34. Okay, we had 2 times 2, and then a 2 and a 17 left. So that's where I got 4 root 34. That is the simplified version, but for this year, I will take either one. Just don't leave it as square root of 544 because that's completely unsimplified. Just another practice problem here. So we have our right angle. So 15 has to be what's by itself. The 10 and the y don't matter, so I'm just going to go 10 squared plus y squared. All that matters is that 15 goes by itself. So then I have 100 plus y squared equals 225. Subtract 100 and I get 125. I'm going to square root. Okay, and again, if we're being technical, we should simplify. I can't divide by 2. I can't divide by 3, so I'll start at 5 and 25, 5 and 5, 5 and 1. Okay, so the best answer would be 5 square root of 5. However, the problem does tell me to round to the hundredths place. So if I were to type in 5 root 5 or square root of 125, either one, when I type that in, sorry, give me 1 second. I've got wrong things going on my calculator. It gives me about 11.18, and then that third number is a 0. So I will have 11.18 as my rounded answer. This problem's a little bit different, and you'll see I actually gave you the setup from the start. So this is an example of an isosceles right triangle. Isosceles, remember, just means that the two legs are equal. And in this particular problem, the legs are my unknowns. Okay, so I know 12 is my hypotenuse, and will go by itself. My legs are both the x's. So I get that x squared plus x squared equals 12 squared setup. Okay, x squared plus x squared equals 12 squared. Before I do anything else, I do need to combine like terms. So I have 1x squared and 1x squared. And when we combine like terms, we just change that leading coefficient. Okay, and 12 squared is 144. I need to divide both sides by 2. So I have x squared equals 72. Okay, I'm going to square root. And I get x equals, if I square root 72, I get 8.4858 and so on. So if this asked me to round to the nearest hundredth, 5 and above, give it a shove. So this would be about 8.49 as a rounded answer. If you wanted to simplify it in a different way, you could do your 2 gives me 36, divided by 2 is 18, divided by 2 is 9. I'm going to go into the words here, but that's okay. Divide by 3 is 3, divide by 3 is 1. So I would be able to make a pair of 2's and a pair of 3's. So remember, that comes out as a 3 times 2 square root 2. Okay, so I could say that this is equal to 6 square root 2, and that would also be a good answer. Okay, either one, I don't care. I have a couple more I want to look at with you. This one is going to be a word problem. In this unit, I actually love word problems because I know every single word problem is going to look like a triangle. No matter what, it's going to look like a right triangle. So Without even reading it, as soon as I see words, I can draw my right triangle and then go from there. So the first thing they tell me is that an 80-foot ladder is resting against a wall. Okay, an 80-foot ladder against a wall, ladders, when we put them against walls, they lean. So this hypotenuse is going to be my ladder leaning against the wall. So that's where the 80 goes. Then I see that a window is 35 feet high. High implies up and down. So we'll assume the window is on the house and not on the ground. Okay, and it says it's 35 feet high. So this side is 35. And then lastly, it asks how far from the building is the bottom of the ladder. Bottom. So I know that X is at the bottom. So looking at my picture, 80 is going to be my hypotenuse. So I have 35 squared plus X squared equals 80 squared. Okay, so I do some calculations. That's 1225 plus X squared equals 6,400. Subtract that 1225. X squared equals 5175. And I will tell you, I'm not even going to simplify this with birthday cake because word problems, a decimal is always going to make more sense. Okay, so I square root that. And I get, oops, sorry, I typed in the wrong number. I square root and I get 71.937, on and on and on. Okay, I look at where it wanted me to round. It said to the nearest foot. Okay, that's the nearest whole number. So X is about 72 feet. The ladder is about 72 feet from the base of the building. Okay. The reason that we pretty much always give decimals for word problems, it makes a whole lot more sense to say the ladder is about 72 feet from the bottom of the building than the ladder is square root of 5,175 away from the bottom. That doesn't make any sense. People are going to be like, what are you talking about? We skipped this slide during notes. If you want to do it, feel free. It will self-check. We also skipped this slide. Again, it is self-checking, so it would be good to practice. This is the last problem we're doing. Again, I see words, so I'm going to go ahead and draw my right triangle. And then I start reading, and I see it's talking about a soccer field. And the soccer field's a rectangle, so I know it is going to break into a right triangle, but I'll go ahead and draw out that rectangle aspect of it, I guess. And it's 90 by 120. It doesn't really matter. This side looks shorter, so I'll put 90 on the left and 120 on the bottom. The coach asks players to run from one corner to the other. So that has to be my diagonal. Okay, that's what I'm looking for. And that's what I want to find. So I want to do 90 squared plus 120 squared equals X squared, since X is the hypotenuse. 8,100 plus 14,400. I do believe that's right. Okay, 22,500 equals X squared. Square root, and you should get exactly 150 as your X value. Okay, so they're going to be running 150 meters. All of the other slides in this, first lesson have a sticker on them or a label, whatever you want to think of it as, but it's bright blue and it says extras. All of the slides that have that bright blue extra sticker are completely optional, and they're there just in case you want some extra practice. That's self-checking, so you'll know you have the right answer. Okay, and that's how it's going to be throughout these notes. Anything labeled extras is optional. And on the second slide in this whole file, you'll see a table of contents that tells you what slide each topic starts on. So um, hopefully you'll find that helpful, and I look forward to working with you on the next lesson.